Good morning, dear students. Today we are going to discuss about racemization, resolution, and asymmetric synthesis. First one, racemization. The process in which one enantiomer, that is dextro or levo, of an optically active compound is converted into a racemic mixture is called racemization. That is the process of conversion of enantiomer into racemic mixture, that is called racemization. It may be carried out by the action of heat, light or chemical agents depending upon the nature of the compound concerned and involves intramolecular rearrangement. For example, lactic acid undergoes racemization readily in the presence of a base through the formation of an unstable enol form. That is, this is our lactic acid, COH, CHOH, CH3, which undergoes tautomerization, that is keto-enol tautomerization. This is keto form which will tautomerized into enol. This is enol. This is hydrogen will shift, this bond will shift to this carbon and double bond will shift to oxygen and O minus getting protonated into OH. That is, this is keto-enol tautomerization. And this we get enol. COH twice double bond COH CH3, which converted into racemic mixture, that is mixture of lactic acid, D-lactic acid and L-lactic acid in the presence of a base. This reaction is known as racemization. Next is resolution of racemic mixture. That is the separation of a racemic mixture into D and L enantiomers is called resolution. Since the enantiomers of an optically active compound have most of their physical and chemical properties the same, their separation cannot be effected by ordinary methods such as fractional distillation, fractional crystallization, etc. And so it requires special methods for the separation of racemic mixture. We have different methods. First one is mechanical separation. In certain cases, two enantiomers form well-defined crystals having different shapes, which are mirror images of each other. In such a case, the crystals of the plus and minus forms in the racemic mixture can be separated by simple hand picking method. Mechanical separation means hand picking with the aid of a magnifying glass and small forceps. That is the earliest method of separation of racemic mixture. Second method is biochemical separation. Biochemical separation found by Pasteur in 1858. That is, in the cases, it is possible to isolate one of the enantiomers of a racemic mixture by the selective destruction of the other through a biochemical process. That is called biochemical separation. It is based on the fact that when certain microorganisms such as yeast, molds or bacteria are allowed to grow in the solution of a racemic mixture, then they selectively assimilate one form, selective assimilation of one form than other. In such a case, it leaves the other form in the solution without any destruction. The isomer left in the solution can be isolated by crystallization. For example, when a solution of DL tartaric acid, that is a racemic mixture, DL tartaric acid is treated with the mold Penicillium gloricum. D-tartaric acid is selectively destroyed. D-tartaric acid selectively destroyed and leaving behind L-tartaric acid. We can separate L-tartaric acid in solution. The biochemical method has some disadvantages. One half of the material has to be sacrificed. It is not easy to find proper organism which will consume one enantiomer in preference to the other. That is other difficulty of this method. Then another difficulty, that is enantiomers which are poisons to microorganisms cannot be separated by this method. Next method is chemical method. Chemical method of resolution involves converting the racemic mixture of enantiomers into a mixture of diastereomeric derivatives by treating with a suitable optically active reagent. The diastereomers thus obtained may be easily separated, taking advantage of the difference in their physical properties and then converted back into the original enantiomers. For example, racemic lactic acid, that is DL lactic acid, when it is treated with a base L-brucine, gives a mixture of diastereomeric salts, that is L-brucine D-lactate and L-brucine L-lactate, that is the diastereomeric mixture. The two salts are separated by fractional crystallization and then each is hydrolyzed to get enantiomer of lactic acid, that is D-lactic acid and L-lactic acid along with our reagent L-brucine. That is the chemical method. This method can also be applied for the resolution of a DL base via its conversion into diastereomeric salts with a suitable optically active acid like DL tartaric acid. The chemical method is the most commonly used method of resolution. Then last method is selective adsorption method. In some cases, resolution can be achieved by passing a solution of the racemic mixture through a chromatographic column of a finely divided optically active adsorbent such as starch, cellulose or quartz. Due to the selective adsorption of one enantiomer by the adsorbent in preference to the other, the two move down the column at different rates, effecting separation. For example, racemic camphor can be resolved into its enantiomer using D-lactose as the adsorbent. Here, the selective adsorption of one enantiomer takes place by the adsorbent. That is the selective adsorption method. Next topic is asymmetric synthesis or enantioselective synthesis. What do you mean by asymmetric synthesis? A synthetic process in which an optically active chiral compound is formed. Optically active chiral compound is formed from an optically inactive compound, that is from an achiral compound without the necessity of resolution. Is called enantioselective synthesis or asymmetric synthesis. What is the need of asymmetric synthesis? When a chiral compound is synthesized by ordinary methods, we get a racemic mixture. However, If such a synthesis is carried out under enantioselective or asymmetric influence of a chiral reagent, one of the enantiomer may be formed in preference. That is, the products are formed in unequal amounts such that one of the enantiomer predominates over the other in the product. Such a synthesis is known as asymmetric synthesis or enantioselective synthesis. We say that in an enantioselective reaction, one enantiomer is found in excess of the other in the product. The quantity by which one enantiomer predominates over the other in an enantioselective synthesis is expressed in terms of enantiomeric excess. So, enantiomeric excess means the excess quantity of one of the enantiomer. For example, suppose that a reaction shows 90% enantiomeric selectivity. 90% enantiomeric selectivity. This means that the product mixture contains 90% of one enantiomer and 10% of the other. That is meant by 90% enantiomeric selectivity. Racemization between equal amounts of the two. That is, here 10% of other will be 10% of each enantiomer, which yields a product that contains of 20% of the racemic modification and 80% of one of the enantiomer. That is enantiomeric excess that can be represented by EE. Enantiomeric excess equal to percentage of one enantiomer minus percentage of other enantiomer. For example, if a mixture contains 75% one of the enantiomer and 25% other enantiomer, then what will be the value of enantiomeric excess? Enantiomeric excess will be equal to one enantiomer, percentage of one enantiomer minus percentage of other enantiomer, that is 75% minus 25%. We get 50%. That is enantiomeric excess will be 50%. That is there is a 50% excess of one enantiomer over the racemic mixture. Here 90% enantiomeric selectivity means 90% one enantiomer and 10% other enantiomer. Then what will be the enantiomeric excess? 90 minus 10, that is 80% enantiomeric excess in this case. There are two methods commonly used for enantioselective synthesis. First one with optically active reagents. For example, esterification of pyruvic acid. This is the formula of pyruvic acid, CH3COCOH, with L-menthol. L-menthol is represented by ROH. This is a simple form of an alcohol. This is not the structure of L-menthol. General representation of L-menthol. And acid alcohol reacted together to form ester. By the elimination of water, it will converted into L-methyl pyruvate, which on reduction converted into L-methyl L-lactate. That is CH3, CHOH, COR. Carbonyl group getting reduced into alcohol, CHOH. Followed by hydrolysis, we get L-lactic acid. So here we can synthesize only one of the enantiomer predominantly. Excess form we get L-lactic acid. Next method with the enzymes, reaction of benzaldehyde with the HCN in the presence of an enzyme called emulsin. It will convert it into cyanohydrin. That is an addition reaction of carbonyl compound with the HCN. CN minus act as a nucleophile and attack on carbonyl carbon, and it will convert it into cyanohydrin in the presence of emulsin. That is an enzyme. Followed by hydrolysis, cyano group getting hydrolyzed into acid group, and we get L-mandelic acid. Here we can synthesize L-mandelic acid only. That is from an achiral compound. So the synthesis of one enantiomer from optically inactive or from an achiral compound is called asymmetric synthesis or enantioselective synthesis. Hope it is clear. Thank you.